Good morning, guys. Week number 4, and it's Monday. I hope you had a restful weekend. Today, I'm going to give you, per usual, feedback on what you submitted already. And then we're going to move forward with chapters 6 and 7. Before I forget, I want to mention that office hours need to be moved from tomorrow to Wednesday. I need to speak. I'm speaking to our student athletes tomorrow. So I will need to move the office hours from tomorrow to Wednesday. However, if you have something urgent and you need to talk to me tomorrow, send me an email and we will figure out a way to communicate on Tuesday and not on Wednesday. Okay. Also, no synchronous meeting this week, but we'll have one next week. All right. So I'm going to go ahead and share my screen. Go to Moodle, our Moodle site. Here we are. For this week, you submitted LO4 and LO5. LO4, the mean score, the average score was 89%. I don't have any specific feedback. If you have any questions for me, please let me know. Same case for LO5, no specific feedback. I didn't see any items that require an additional attention. The mean score is 87%. Some general feedback, again, spend some time studying material. All the answers are in the book and or those videos, okay? So make sure you spend a little bit more time. I would like to see those scores to get a little bit up. I would like to see higher scores, not just because better grades are just something that just grades, like they mean something very important to me because the numbers are high. It just, for me, it means that it's a better representation of what you understand from the material. That's what I was trying to say. So spend a little bit more time studying the material and those scores will go up as well. All right. So for next week, we have LO6 and LO7. All right. Deadline again is Sunday midnight. And today we're going to cover these two very important chapters, which again have to do with your final learning opportunity. So as we go over these chapters, please start thinking about your ideas and what you're going to do. If you can, and you already kind of know what you want to investigate in your proposal, start taking notes, making notes, start thinking, trying stuff, looking into the literature, start writing a little bit, see how it would look like or what you need or what you're missing. Okay, start playing with it. The more you play with it right now, the less you're gonna have to deal with it later on. Okay, now that this bike went through and there's not so much noise, I'll stop sharing this and I will move to our slideshow for chapter 6. 1 second. There it is. All right. Chapter 6. Understanding research and clinicians' perspective of basic applied in clinical investigations. So what we're going to cover today, again, in terms of this figure, we're going to see, we're going to talk a little about how to design the study, a little bit how to analyze data down here, and also what's out there. Okay, so we're going to cover different parts of it. Pretty exciting stuff. I hope you like them. If you have any questions, please let me know. Again, it's impossible for me to cover every single sentence from the textbook, but I will do my best, and I will do my best to give some additional examples so you understand the material a little bit more or deeper. Right, these are the terms. If you're not familiar with them, they may look a little bit weird, like Bayesian statistics or skewness or kurtosis. But as we go over the material, and again, you go over the material by yourselves and you go all the way to the end of the chapter, you'll see the definitions of all these terms. Spend time, Google them. If you need more information, make sure you understand, okay? All right, I'm not gonna go over all these details because you can do that by yourself. That's just historical data. The basic idea behind this is there was a dichotomy concerning science, basic and applied science. Okay, basic science is more about creating the theories, and applied science is more about testing the theories. Which one is more important? None of them. Both of them, actually. So you can have you can have applied without basic. And applied then by testing the theories, it will just loops back and informs basic, and then basic informs again applied. So they coexist, and they have to coexist. Both of them are important, and it's not that people who are more into applied are better than people who are more into basic. We all need each other, and we need that information. We complete each other pretty much, okay? So if you see science from this perspective, from this dichotomy, we have basic and we have applied, okay? Both important, both needed. You can read in the book how it started all the way from ancient Greece and Aristotle all the way to right now, okay? These are some questions that you have to ask yourselves even now doing this proposal. So what is the purpose of my research? Okay, and who is gonna use this? Who's gonna read it? Who's gonna get affected? Who's gonna apply it? The statistical analysis approach. Of course, how am I gonna analyze the data? And before even analyzing the data, how I'm gonna design the methods of this study, which is this part of this, right? How do we're gonna talk about over-interpreting or under-reporting my findings. Okay, these are questions that we're gonna talk about, cover today, or try to answer. And at the end, how do I present information based on the audience? Okay, and that's really important as well. Let's see if this works. All right. Again, as I said in the intro of this video, this information will be important to you for many reasons, including your FLO. So framing that research question, okay, we said that we start wide and we start big, but most of the time, and a lot of times we have that issue, the research question has to be very, very, very specific. The research question is gonna have elements such as the target population and the dependent or independent variables that we're using. Okay. Are you gonna manipulate the variable? If you are, we're gonna see what kind of design is this, right? So we're talking about some kind of treatment. What kind of intervention is this? If you are not, if you cannot or will not, do not manipulate the variables or the intervention, then we're talking about a different kind of design and a different kind of question. At the end of the day, if we put in terms of your FLO, the questions are just endless, right? There are an infinite number of questions about everything, pretty much. Some of them have been answered. Some of them have been partially answered. So at the end of the day, we use information that we know, and we build on that information. And other people after us will use that to build more right? And that's how our fields keep progressing and keep evolving. So use what we know, and then try to answer those additional questions or different questions that haven't been answered. Okay. All right. I will see in a little bit a pyramid. That pyramid is it puts the evidence in a kind of sequence, which means first we should have this before we have evidence of this type, and then of that type, and then of the next type. It doesn't mean that one type of evidence is more important than the other, because again, they have to coexist. One exists because of the other. Okay, so we need all this, all these types of information. All of them are important. All of them are there for a reason, and all of them are answering questions. Okay. Now, let's go here. As you can see at the bottom, we have some ideas. Everything starts from an idea, but you can see that starting from an idea all the way to synthesizing with a systematic review and meta-analysis, um, everything is important. So in the beginning, we'll have some ideas. Okay, maybe some anecdotal data, trial and error, right? And then we have some kind of bench science, as we say, some kind of models or some kind in vitro studies. And then, as you can see, we move to epidemiological data or epidemiological evidence. And that's a big part of our field, right? We'll have case studies. For example, we are having next week uh, the Texas ACSM conference is taking place, right? Some of the students of our major are presenting research, and in some cases, they're case studies. Okay, it can be a clinical case study, so something that is, and I'm covering right now stuff that I have in the next slides, but we might as well. Um, Clinical case study, so something that it is unique and we should know because we learn from that, even if it is 1 out of 1 million cases, right? Um, Cross-sectional studies. Cross-sectional studies are snapshots, right? So today I can collect data from usually a large sample, and I can tell you, for example, the correlation between mental toughness levels and mental health levels in collegiate D3 student athletes. But that's today. It's not yesterday. It's not tomorrow. It's just a snapshot. Okay. Case control studies. I have two groups, and I just follow them. And I take. I'm just. It's just a cross-sectional study with two groups, pretty much. I get data from. I have two conditions. All right. And cohort studies are more longitudinal, so I keep following them. Specific group of people. Let's say that they have a high risk of cardiovascular disease, and then I follow them, and then I collect data. Right. That epidemiological evidence now feeds the control research, right? And when I can randomize, I have what we have called as a gold standard, RCTs, right? When I cannot randomize or I don't want to randomize or it's unethical to randomize, we'll talk about that in a little bit, then I have control clinical trial, right? That's controlled research. And the control, then based on that information from control research, people, when we have enough, they can create those systematic reviews. And if they want, they can take it a little bit further and look for the effect size and create meta-analysis. So again, from just having an idea about something until we synthesize a large amount of data, everything is important, from the idea to the synthesis and all the way in between, right? One informs the other. That's what I want to say about this. This is just sequence. Okay, that's a hierarchy of sequence, not of importance. All right, I talked a little bit about that already. I'm just gonna see what I haven't talked about, and I'll just add. Talked about the case study, describe some specific phenomena. What I wanted to say about case studies, and a lot of people forget that case study is not always about one person. What am I trying to say about that? So when you're the unit that you're researching is one, that unit does not mean that equates to one person. So another example from Texas ACSM. So we did research with the police academy in Serbia. Okay, that was had to do with COVID-19 restrictions, and it doesn't matter, but it was just about one academy, right? Our the unit that we investigated was one academy, right? So that is a case study. We submitted also, and this submission actually went to the finals. We'll see if Nicole will what's going to be her place at the very end, because there's a competition. But we investigated a basketball team. Right, we try to see some correlation between strength and conditioning results and efficiency indices that we have at the end of the season, right? So how we can predict performance based on performance indices from uh, strength and conditioning data from fitness metrics that we collect before during the off season. So that was about one basketball team. So again, that basketball team had 10 men and 8 women, right? So 10 males, 8 females. Still, one basketball team, one program, so one unit. So it really depends. So what I'm trying to say here is that case study doesn't mean that it's just one person. Okay. There's that. Cross-sectional, we said it's a snapshot. Yes, it can show the direction of a relationship and the intensity, whether strongly related or not, right? But we cannot infer causality. And I used some examples last week, right? I hope you remember. The case control study, as I said, compares two groups like smokers and non-smokers. In the cohort study, we follow a group of people that may have something that we're interested in. And the good thing about cohort studies is that it's longitudinal. It's not just one snapshot, such as the cross-sectional studies. And that's one of the weaknesses of the cross-sectional studies, right? It's one measurement. All right. Why do we need controlled clinical trials? So maybe we need some pilot studies to make sure we can refine those research questions that we have. So here in the control clinical, we can have several groups or one group, really depends. And can also have randomization or not, right? And if we have randomization and more than one groups, we will talk about RCTs, right? But as you can see up here, we have the controlled clinical trials, and there it can be impossible or unethical to have more than one group. So everybody has to, we can make somebody small, for example, right? So we may have just one group of smokers, all right? That's an example. All right, we're going to talk about this in a little bit. All right, what is the bio psychosocial model? All right, so this particular is a model of illness and injury. And this particular one has to do with the recovery of an injured athlete, right? And we could use just one of the three sciences, biologic, physiologic, or social, to explain the recovery. However, as you can see, they interact with each other. And we cannot use them just separately because there's no real life. So here you see how they can affect the individual separately, but also together. Okay, and this is the biopsychosocial model, and that's the way to do research, and that's the way to explain a phenomenon. All right, and personally, I do it a lot because explaining an injury is just not a physiological phenomenon. That's not just it, right? So a lot of times I have to work with exercise physiologists, right? I have to work with other people, and then in conjunction, we're trying to help the same athlete, right? We're talking about interdisciplinary work. All right, qualitative approach. Not everything can be measured. Not everything can be quantified. Is qualitative better than quantitative? Depends. Depends. What are you investigating? Some things cannot be investigated quantitatively. They can, especially if you want to go into depth, especially if you want to look into the whys. Okay. Um, Now, it is difficult to compare qualitative studies unless they have a very specific standardized way to do it. And it's not that qualitative is not standardized. There are specific ways to do qualitative research, and there are specific ways to analyze qualitative data. It's just different. It's not better or worse than quantitative. Okay. This is another example. So here we have the same case. We have somebody who's injured, and we have again the same model, the biopsychosocial model, but we see it as a continuum, and we see how all these different aspects, right? We have the injury, we'll have the impairment, the loss of function, we'll have the degree of disability, all the way to the quality of life. Quality of life, as you can see, includes everything, right? But you can also see how these different parts affect each other. So impairment, injury will affect impairment, impairment will affect loss of function will affect disability, and disability will affect quality of life. So we can see things in a very, in a specific framework. We can see just impairment, but also you can see that there are different kind of interaction happening that we should investigate if we want to have a more holistic way of doing research and explaining a phenomenon, such as an injury, right, or recovery from injury in this case. All right, so let's talk about variables. So we talked about this before, right? And we have to define our variable. What's the definition of our variable? What's the operational definition of our variable? And is it, what we will group them in terms of nominal, ordinal, interval, and ratio, right? We talked about nominal. We'll have groups of people, men and women. Let's say based on sex, right? That's it. That's it. So based on sex, we have males and females. There, and we'll talk about parametric and non-parametric in a little bit. Non-parametric is a distribution-free kind of data, and we're talking about ordinal and ranked data. So the non-parametric here is, for example, I wouldn't, let's say in terms of analysis, I put a number on males, which is 0, and females 1, right? And then I put it on columns, and then I try to do some kind of analysis based on that. Cool. If I try to find a mean, that wouldn't really help me in this case, and we'll talk about that in a little bit. But for now, make sure you understand that we put the data in groups, okay? And there's no order. Ordinal, there is order. And I've used this same example before. We have low risk and medium risk and high risk of cardiovascular disease. These people are grouped 1, 2, 3. If we want to put numbers on it, okay? When we put them in columns or on Excel sheets before we do some kind of analysis. Right here, again, we're talking about non-parametric statistical methods. We're going to talk about them in a little bit, but there is some order. Okay, it is different to put high before low or low before high. In the nominal, males or females, it doesn't really make any difference. Interval now. So here we have differences between the values. And the magnitude of those differences has a meaning. Okay? But there is no zero. There's no reference point. Here we're going to use parametric statistic methods, and we'll see about them again in a little bit. So here we have data that the magnitude difference between the values has a meaning. So from 7 RP to 8 RP compared to 9, the difference between 9 and 10. Okay? And the ratio, here we have 0 has a meaning, it exists, and it's a reference point. And that could be, I used it before, that could be an example of degrees of Fahrenheit or Celsius, or a percentage of repetition maximum. All right. Design. The design, as I said before, is really important, because the way we design, as we said, if we mess it up, if our design is messed up, we may not have the chance to fix it with analysis. All right. So, do we need new data? Sometimes we have data already stored somewhere, and we take them and we analyze them differently. Do we need them? Do we need this specific intervention, or somebody else has done it before? What about the dependent variable, the outcomes? Have they been acquired before? Is an RCT ethical? In our case, a cohort study can be retrospective or prospective. What's best? So, and then you can see the time of completion and what is the risk of the intervention. So, how are the participants benefiting? There's high risk in this kind of intervention. So there are a lot of questions to answer as you're thinking about how to go about your design. All right, uncertainty and consequences, and this is a part of a quote from our book. What we're trying to say here, we're going to talk about 3 approaches, if I remember very well, is we need to address the uncertainty and the consequences of what we're doing and our results. Right, so what is the probability that the results of an experiment would occur if the difference observed do not really exist in the population from which the sample was drawn? So a lot of times you hear about that p-value, right? In simple words, it means how certain are we that whatever happened, it didn't just happen randomly? How certain are we? So, well, when we select a p-value of 0.05, we're 95% certain. So when you hear that term, it is statistically significant, and the p-value was set at blah, 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 that p-value tells you that we are 95% certain that whatever we observed, whatever happened, whatever differences we see, we're 95% certain that they're not random. That's the more simplistic way to say it. Or if we do the same thing 100 times, 95 out of those 100 will get the same results. Okay? But the statistical significance is different than the clinical significance, right? And here is this is really important to address. So you see here, something is significant when the probability that a type 1 error has been committed is lower than the risk of being wrong the investigators were willing to take. Cool. But whatever differences we saw and whatever differences we named as statistically significant, is it worth it in terms of practice? So This is very nice, figure, very, very nice. So I want you to spend some time here. The confidence interval that we're talking about uh, is more about a range in which the population value is believed to lay at a given level of certainty. Usually we use a 95% confidence interval that has to do with the p-value, right? So a 95% confidence interval of mean differences provides knowledge within 95% certainty as to where a population mean difference may lay. So here we have 5 examples. Before we talk about those 5 cases, we need to understand that the black center line means that there's no difference between the group means. That's the statistical significance line. Then we have the teal vertical line, which is difference is large enough to be clinically important. So this has to do with the practical importance, right, of the treatment, of whatever treatment effect we have there. And then you see the confidence interval is the pretty much here is the size of that line that you see underneath those letters, right? And I said that 90 this kind of confidence interval 95% has to do with how certain you are that the population mean difference may lay in there, right? Okay, so case 1, statistically significant, yes. Clinically significant, no. So if I was just reporting the statistical significance, would that be enough? No. B. Statistically significant? Yes. Clinically significant? Yes. It's a base case scenario, right? Excuse me. C. Is he statistically significant? Well, you see that the confidence interval, that line that you see, some of it is on the right, on the left side, right? So would say no, right? And it's not statistically significant either. What about D? D looks like it is statistically significant, but when we have to talk about the clinical significance, we're not sure. E now. E is a very interesting case because based on that confidence interval, there are cases that are not statistically significant and they can go all the way to the clinical significance, all the way to the right. So that population mean difference is that we are getting here is those results are very, very interesting. What we're trying to show with this is that statistical significance is awesome, but it is not enough. So a lot of times you will see that we report more than the statistical significance. Okay, just for those reasons, because we're trying to prove that whatever we found that was statistically significant is practically significant as well, because that's what we're looking for, right? Something that has some practical importance. And another thing that is important to consider is that there are individual decisions and there are individual differences, right? And each patient doesn't really care about mean score. As you can see in the second bullet point, patients really want to know whether a particular intervention improves the odds of a successful outcome in comparison to an alternative intervention, right? And Bayesian statistics, we're not going to go into detail today. That's not something that we should analyze in this class, but that's what they do, right? They help with to express that difference between uncertainty and certainty, right, on an individual level. All right, descriptive statistics. I hope you've heard about that, and I hope you've read papers, or when you're reading papers, you'll see that they There are some kind of metrics that, as you can see here, they characterize the data set. So, um, for example, in our basketball team that I just talked about, we can give a mean 8 and a standard deviation of that, right? So mean, as you can see, a standard deviation is very common, right? Central tendency and dispersion. That's really important to know because that will help us in a way later on evaluate the results that we're getting. And then, but if we have nominal data, there we have mode and frequency. And mean doesn't really say anything. So if I go back here, we talked about nominal data and let's say males, females, right? So here we have groups, no specific order, doesn't really matter. So if I give you here a mean of 1.2 or 0.8, whatever, what does it mean? Nothing really. So what we're doing here, we're giving frequencies. Frequency, we can say 70% were females. Okay. Nothing really here, but let's focus on this one. All right, probability. What is probability? The number of favorable outcomes divided by the total number of possible outcomes. So if we do it 10 times, 8 times, this will happen. So there's 80% probability of this happening, or 20% of not happening. Okay. Odds, the probability that an event will occur divided by the probability that it will not occur. So pretty much we would divide 80% by 20%. Okay. Relative risk, the probability of one event divided by the probability of another event. So here we have 2 different events. An odds ratio, the odds of the interest group divided by the odds of the comparison group. So here we have the odds and we divide what we care about, the interest group and then the comparison group or control group. Different kinds of ratios just to give us probability. Okay. All right, let's talk about parametric and non-parametric. So in parametric, we have in statistics some assumptions such as the normality of the sample that is satisfied, and that's why we're doing parametric methods, right? In the non-parametric, as I said before, they're called distribution free because we analyze data and we use different methods. We analyze data differently. Classic examples you see here, Spearman's law is very common. What we're trying to figure out in any way is some kind of association between variables, not the difference between group means or medians. When I have one variable, I would do linear regression, right? And then I'm comparing that independent variable to the dependent variable, to the outcome variable. We'll talk about this in a second. When I have more than one predicting variables, right, independent variables, then I would use multiple regression. So let's say I want to compare sex, stress. One independent, one dependent, linear regression. Okay, I want to compare stress to sex, age, chronic disease or not chronic disease. What else? Race, ethnicity. I could go on. In this case, I have a lot of predictors. I'm trying to figure out what's going on with anxiety scores, right? No stress, let's say anxiety. So there I would do multiple regression. That's what I'm trying to talk about. All right, and that was about it for this chapter. Again, if you have any questions for me, please let me know. All right, let me try and bring up the other chapter 7. Okay. See you. Experimental design. And sometimes, I'm trying, guys, to explain ideas that we could just have just one course, just about one thing, such as this experimental design, just one whole course, or more actually, maybe, right? So I'm trying to simplify things and try to explain them to you the best way I can. Um, but just know that these are we're just not going into a lot of depth. I'm just trying to keep it as simple as possible, not confuse you. All right. So this is the first one about experimental design, and here we're going to talk about the independent variables. So as you understand, we're going to talk about designing a study, and we're going to talk about figuring out the variables of the study, and especially we're doing some experimental design. A lot of terms, don't freak out. We'll go over all of them as throughout this whole video presentation of this specific slideshow. Okay. Again, think about your FLO. What would be the best research design to answer? Excuse me, the question that you have, your research question. It won't be perfect. There will be limitations, and there also will be delimitations of any kind of design. However, our goal is here to minimize the limitations, because as I said before, we can't really fix with analysis one bungle with design. Okay. All right. So let's identify what is a variable, a factor, right? That can change or in a way will be manipulated to change as an intervention. Anything that will affect, plays a role in your in answering your research question. And as you can see, they can be independent, dependent, and constant or confounding. So in terms of now grouping the variables, dependent will be what is that would be like your main interest. So if you were looking into a specific heat training and body fat, what are you actually looking into is body fat. So body fat will be your dependent, okay, on this side. Independent will be that specific intervention that you want to test, okay? Now, if you think that something could affect the results and has to be taken into consideration, otherwise we'll have some kind of contamination of the results, such as gender or sex, then you put that in there. That's another variable. Sex is another variable. Age is another variable. Training age is another variable. Status. And we need to control for those variables, because if we don't take them into consideration, right? Although it's not our dependent and it's not our independent variable, these other variables can affect the effect of this on this, the effect of that heat training that you're thinking about protocol on body fat percentage, right? So again, think about your FLO, think about what you want to see changes in and what you think will predict those changes. So here we'll have the outcome variable, which is body fat percentage or dependent. And then we have independent, which is the predictor, the heat training protocol. Okay. But there are other variables: diet, sleep, as I said, sex, age, whatever you may think, training age, training status, that could affect the effect of this, which is the HIIT training, on this, which is the body fat percentage. So we need to take them into consideration. That's what I want you to remember. All right, so here, it's a nice table. The independent variable is a known factor. The dependent is the unknown factor, right? The dependent is what you're going to measure, and that's the outcome. The independent now, you can manipulate it or you cannot manipulate. You can control it or you can just observe it. If as it goes up and down, it doesn't really matter. It depends. It may have different levels. We're going to talk about levels in a little bit. So by levels, you can have different protocols. Or if you give me caffeine, you can give me 50 milligrams, 100 milligrams, 150 milligrams, 25 milligrams, different levels. Group classification, elite, intermediate, and novice. I don't know. You can play with this a lot, right? And here you have the dependent variable. Can you have two dependent variables? Yes, you can. Yes, you can. You can design whatever you want to design, and you can put as many variables as you want to put in there. I just want to say that do not make it that complicated, and not only for the purposes of this course, but a lot of times we're trying to do those amazing designs, but you know, as we increase the level of complexity, we have to deal with a lot of, we increase the number of issues we may need to deal with later on. And it has to do with either data collection or attrition or cleaning the data or analyzing the data and so on and so forth. Just that. I'll stop here. All right. So here we have a 2x3 design. So we have males, females, and then we have no dose, low dose, high dose. Right? And all this is on this side, the independent, right? Okay. So you can test all of this on the effect of all these different kind of conditions and their combination. So you have a 2x3 design. So you can have control male, control female, low dose male, low dose female, high dose male, high dose female. And you can see the effect on something that you're looking at, okay? And we're going to talk about between and between subjects and within subjects. So if you have more than one group, you usually look between subjects. So you have a control group and one or more other groups, right? If you looking about within subject, then the way you're doing the analysis, you have usually one group and the same person here was taking, let's say, low dose, and then later on you gave them high dose. So the same person was the control of himself or herself. Okay, I'm going to explain more right here. Okay, all right, let's see how we're going to put this. First of all, although we put together between group and between sub, they're not the same thing, but we're just trying to simplify it. Between group and within group, something has to do with ANOVA. And anyway, I'm just going to describe it as between subject and within subject. Both designs have weaknesses and strengths. I love within subject because pretty much you compare you with you. All right. So you need less people. You have more power. We're going to talk about power, statistical power in a little bit. And by the way, in your folder about your FLO, in order to determine the sample size, right, I'm giving you enough information about G-Power. G-Power is a free software that will help you figure out how many people you need for your designs in order to have enough power. So you have those participants, and then you use the same participants, one group later on, to do something different, and then you compare and contrast the difference that you see as you manipulate let's say, caffeine dose on the same people, and you're trying to see what effect that has on, again, body fat percentage. Okay. So less people, but you need them for more time to do more things. So you have more attrition. So you lose more people as you go, right? You don't need them just for once, for example, or twice. You need them. It's a longitudinal design, right? You get more power, and it has a lot of strengths, but also let's talk about weakness. When I give you caffeine or any kind of supplement, for example, I need a period for that supplement to wash out. Or if I teach you something, let's say you're going through some kind of psychological skills intervention and I taught you how to do imagery, how am I going to make you forget it? Right? So sometimes it's not that we don't want to do within, it's we can't. We need more than one group. Now, in between subject, you have multiple groups and you compare the groups, okay? Different subjects, I'm sorry, you compare the subjects between the groups, and you need more people. You require less from them, but it's not a very powerful design, and that's why you need more people to increase the power. Okay. The best thing about within subject, and I want you to remember that, is we talked about confining variables, right? Things that we should control. So we're sure that whatever is happening on this side is can be accounted for whatever is happening on the effect on this side, right? Who's more similar to me than me? So by using the same person, I'm really controlling for a lot of variables. Me compared to a random other person is like me compared to myself in 5 years are more similar. We're more similar than me to anybody else right now because it's me. It's me. I'm the same person. So again, I'm not a perfect. I'm not. I'm not my twin, right? If I compare me to me 5 years later, but still, I will be more similar than anybody else. So think about confounding variables and think about how much you control by just using the same people, right? That's the thing that I like the best about within subject designs. All right. All right. Yeah, I said all right 2 times. Cool. Research design, and let's compare experimental to non-experimental, and then in between you see we'll have quasi. All right. First of all, quasi and non-experimental can be retrospective or prospective, while true experimental can only be prospective. From the non-experimental, as we said, we can have some kind of correlations, interrelationships between A and B, but there's no causality. We don't know the why. Okay. There's no need for randomization, and we don't really control the variables. We just, let's say, observe. Let's say it's a cross-sectional design. It's a snapshot of mental toughness and mental health. Boom, done. All right. Quasi here, for whatever reasons, we cannot have a true experiment, which means we cannot have multiple groups and randomization. So we can have maybe one group, and that happens a lot in our field. I've done a lot of research like that. So I come to your team and you're a strength and conditioning coach, and I'm asking you to do something. I can't really ask you to break down your team into 2 groups. That's not going to happen. So if we do something, we're going to do to everybody. Okay, so that would be a quasi. I have some control, right, on the variables, but it's everybody. Everybody will do it. What is external validity? External validity is about extrapolating the findings to the population. So in order for this to happen and have strong external validity, my sample has to be representative of the population. True experimental is when I said we have multiple groups, we have a control group, and we have randomization. So there, yes, I can do, I have causal inferences, right? I can infer causality. And high degree of control because I can manipulate the let's say the intervention, the variable, right? And it can only, as I said, be prospective, and it has more emphasis in the internal validity. So if whatever differences I see on the dependent variable, it really depend on the um, manipulation or the differences of the independent variables. Okay. All right. So in the experimental design, I have a control group. That's important. And what's going on with the control group usually, a lot of times, I have, I'm taking them through placebo, which is something that looks like a treatment, but it's not. Why am I doing this? Because I don't want them to know if they are taking part actually in that intervention, if they're or not. So I have that caffeine pill. I have two of them. They look the same, everything, but one is just sugar, right? And I just give them to both groups, and they don't know if they're actually taking the caffeine or not. Okay, so that decreases bias, because just by thinking that you are participating or not participating to something, that will affect your performance. Okay, now if I'm only blinding them, so they are the participants are the only ones who don't know what's going on, that's single blinding. If the investigators don't know either, that's double blinding. Is that better? Well, in terms of bias, again, when I'm interpreting the results, or if I'm seeing the results, and I'm trying to interpret, if I see the scores and I know that you were part of the treatment or not, that may affect the way I interpret them. So just from that example, you understand that double blinding is better in terms of bias. So lower bias, higher quality of research. What is the placebo effect? The placebo effect is that we see in difference in the performance or whatever we're looking for, even the placebo group, right? Which is very interesting. The Hawthorne effect, again, is something that we should take into consideration, and that's why we have those control groups, is that just by somebody knowing that I'm being investigated and taking part in something, I'm just doing better, right? So that's another thing, another way to consider when we talk about bias. So how are you going to select your subjects when you're doing experimental design? We need to identify your target group, the study population, and get a representative sample. Okay. Now, can you use a convenience sample? What is a convenience sample? We use it all the time, right? So I go into the classroom and I use my students, or I go to my team and I use my athletes. The good thing about convenience sample is that usually they are invested and have less attrition, right? But I may lose their presentation, like, because again, that basketball team, right, that we investigated doesn't mean that all basketball teams are the same. That's why it's a case study. That police academy that we investigated doesn't mean that all police academies are the same. So again, that's a case study. Okay, so we're losing in terms of external validity, in terms of extrapolating. The degree to which the sample represents the population affects the power of the study, as you understand, and that's why I talked about external validity. And of course, now we have to talk about power as well. Inclusion criteria. What is inclusion criteria? Well, is criteria of the participants that will be included, and then also, of course, we have the exclusion criteria, which are characteristics that of the participants that would make them not participate. Okay, why would I do that? Well, because again, I'm trying to confine, because I'm interested in something very specific, like only females, only Black females, or Asian Pacific male, whatever I'm doing. So I may have inclusion and exclusion criteria, which, again, they are there because they help me create the design that answers my research question. and think about all these things, because I'm going to ask you about the inclusion and exclusion criteria for when you write your FLO. Now, randomization and matching. Okay, so randomization is, I have 20 people, I need two groups, I just randomly assign them to groups, and the groups have conditions. So one condition is control, the other one is intervention, co-con. Matching is more about confining now, and if I want the two groups to have similar age or similar representation based on sex, then I'm doing more of a matching thing. That's the difference. Single nose ratio is fine. Systematic errors are errors that happen all the time. So the scale is messed up and it always shows 2 kilos more or less. That's a systematic error. That's one direction, and it really affects the result, but it's really easy to fix once I detect it. Random is just random. I couldn't predict it. I didn't know what happened. It can just be this direction or the other direction. It's just random. It doesn't really affect that much, because in terms of frequency, that's what I mean. If it's low frequency. All right. So that's for today. I hope you enjoyed it. I want to remind you that we don't have any synchronous meetings this week, and the office hours are going to be moved from tomorrow to Wednesday. Two LOs, LO6 and LO7. I have my notes right here. If, however, concerning the office hours, you need to meet with me tomorrow, let me know and we can schedule something. Otherwise, 8 to 12:30 on Wednesday. If I don't see you on Wednesday, you at least see me next Monday. In the meantime, lift intentionally.